The tangent to the curve y is equal to x cubed minus 3x at the point a cubed minus 3a, also passes through the point 2, 0 for precisely, well, for how many values of a is it asking that? Okay, so the way I'm planning to do this is to, I'm going to sketch a curve, but it's not necessarily going to be accurate for this function, x cubed minus 3x. And I'm going to write down the equation of a line for a tangent to that curve at the point given. So in particular, when x is equal to a. So once I have an equation of a line that will have the parameter a in it, we're looking for when that crosses the x-axis, so when y is equal to 0. So I'll just solve for the value of x for when y is equal to 0, and see if there are multiple values. Well, let me figure out exactly what we're going to do when we get there, but we're going to see if there are multiple values of a for allowing this to happen. I know I said I wasn't going to make this completely accurate, but the function will look something like this. I'm exaggerating a little bit. Choose an arbitrary value of a. So this is the point a cubed minus 3a. And we have a tangent line at this point. Okay, so the slope, let's first take the derivative of this. Y prime is equal to 3x squared minus 3. So the slope, let's call it m, is equal to 3a squared minus 3. And so the equation of the tangent line is y minus a cubed plus 3a divided by x minus a is equal to 3a squared minus 3. To rearrange this a little bit, y minus a cubed plus 3a is equal to x minus a, 3a squared minus 3. Y is equal to x minus a, 3a squared minus 3 times, or sorry, plus 3a, plus a cubed minus 3a. And so we want this line to pass through 2, 0. So y is equal to 0, x is equal to 2. And now we're trying to ask ourselves how many roots are there to this equation. I think I'm just going to expand and see if there's something we can figure out about this. Okay, so overall I have a cubed minus 3a squared plus 3 is equal to 0. And how many roots will this have? Okay, well, it's a cubic equation, so the number of roots has to be odd. It's either 1 or 3. And I note that if a is equal to 3, okay, if a is equal to, let's call the thing on the left f of a. I'm not going to guess and check here for values of a that work. But I note that f of 0 is equal to 3. And it just shoots up, it just increases like that to the left of 0, does it not? No, not necessarily. In fact, does it at all? What is f prime of a? 3a squared minus 6a. Maybe I will just guess and check a few values to see if I can find where this thing crosses 0. There will be at least one negative root. What is that f prime again? F prime of a is equal to 3a squared minus 6a. When a is negative, this is positive, so it's always increasing. Okay, so I had that completely backwards before. The question is, it'll have some kind of, it might have like a turnaround of some sort. Why don't we find where that turnaround is? 3a squared minus 6a is equal to 0. So a equals 0 works. There's a horizontal tangent there. But other than 0, we have 3a minus 6 equals 0. So a is equal to 2. What is f of 2? 8 minus 3 times 4 plus 3. (11 minus 12 is equal to negative 1. Okay, so this turns around, becomes negative, and then turns around again, becomes positive. So there have to be at least 3 roots here. Three values of a is option D. Hoping that I didn't make any silly mistakes. Let's just do a quick run through of my algebra to make sure I didn't make an algebra error. So the slope is 3a squared minus 3. So I have the equation of the line y minus one of its values divided by x minus its corresponding value is equal to the slope. rearrange this. Force it to pass through the point 2, 0. And expand 6 a squared minus 6 minus 3a cubed plus 3a okay, and then yeah, I think this is fine. So I'm pretty confident in that, but I'll let you know if I find any mistakes. Thanks for watching.